So far we have seen how to get files into HDFS from local file system and also copy from one location in HDFS to another location in HDFS, and also how to get files from HDFS to local file system. Now when the files are copied within HDFS, the files are divided into blocks. Let's get into the details related to block size in HDFS and how it controls the number of blocks and how it is relevant with respect to the distributed word within HDFS. HDFS stands for Hadoop Distributed File System, and the distributed is achieved using block size. It means the large file will be physically stored on multiple nodes in distributed fashion. Let us review the HDFS FSCK output which you have seen earlier with respect to this file. The file is approximately 1 GB in size and you will see 9 files. When I say 9 files, 1 file for each block. Let's run this command first to see the size of the file. You can see it is approximately 1 GB. It is actually 1 GB plus 28 MB. You can actually get more information using this command HDFS FSCK on this file. We have seen this earlier as well. You can see that it contains 9 blocks because the file size is 1 GB plus 25 MB. Average block replication is 3, which means each of the blocks is cloned into 3 copies, and those 3 copies are copied onto 3 worker nodes in our cluster. That being said, you can get details of each and every block here. You can see it has a block ID. So this is nothing but block ID. This is block index. So this is first 128 MB of the file. This is second 128 MB of the file, and this is the block ID. This is the third 128 MB of the file, and this is the block ID, so and so forth. And the reason why it is divided into 128 MB is due to a property called as dfs.blocksize. How to get that information? You just have to look into this HDFS site.xml file under this location etc Hadoop conf, and you should be able to see the block size property in it. If it doesn't exist in the file, that means it is using default, which is nothing but 128 MB itself. You can run this and you should be able to see the details. This is equal to 128 MB. So this is the property file which will control the behavior of HDFS components in the cluster. Now let me clear the output, and then let's determine the number of blocks for this file, which is under actually data retail DB. This is a local file system. You can get the details of this file by running this. It is of size 2.9 MB. Let us determine how many blocks will be there. Because the size of the file is less than 128 MB, there will be only one block, and that block will be of size 2.9 MB storage in HDFS, assuming replication factor as 1. If the replication factor is 2, the same block will be copied onto 2 worker nodes, and each block will be of size 2.9 MB. How to validate? You just run HDFS FSCK. The path is nothing but user $user, or you can also say public retail DB, and then you can say files and blocks. Then you can run this and you should be able to see the details. There is only one block associated with this file, and the size is approximately 2.9 MB or 2.8 MB. If you want to get the locations, you can also add locations here. So when we copy this local file into HDFS, it occupies approximately 6 MB because we have 2 copies of the block, and each block will be of size 2.9 MB, even though at cluster level block size is 128 MB, which means if the size of the file is less than the block size, it occupies 1 block of the size of the file. And based upon the replication factor, there can be as many copies as it is defined as part of the replication factor. We'll talk about replication factor as part of the next topic. For now, keep in mind that in our cluster, the default replication factor is 2, and this file is copied with default replication factor itself. Now let's determine the number of blocks for this file. Again, this is the local file system, and hence you should be able to run this. It is approximately 2.4 GB. And when you actually copy into HDFS, you will see 18 128 MB files if the block size is 128 MB, and 169 MB file, because we have approximately 2.4 GB, which is 18 times 128, which will be close to 2.4, plus whatever is remaining will go to the last block. And here we are assuming the replication factor to be 1. We already have the file in HDFS. You can run this and you should be able to get the details about this file as well. If you go to the report here, it contains 19 blocks. Average replication factor for this is 2, or average block replication is 2, which means there will be 2 copies of each block. And you can see that all the blocks except for the last one is 128 MB, and the last one is just 64 MB, close to 64 MB. This is how the block size plays the role of distributing the file into blocks, and these blocks will be distributed across multiple nodes in the cluster.